Good evening, everybody. It's a nice June evening, and I am preparing the last few videos for class. In this video, we're going to start investigating what work you'll be doing in Module 3, which is the Drawing and Dimensioning module, where we're going to take the models that were created in Module 1 and Module 2 and prepare them for engineering drawings for manufacturing by putting them on sheets and putting dimensions on them. So there'll be lectures about dimensioning, and I wanted to start to talk about how we're going to be dimensioning in Fusion. Okay, so this is going to be kind of a combination video or series of videos. I'm going to do multiple ones, but we're going to be referencing to a large degree the workflow that I want you to follow when you're dimensioning. Okay, and I have the workflow here. This is from the PowerPoint that you guys will be given on Canvas. And we're going to follow a two-step dimensioning procedure, and I'm going to go through that procedure in Fusion for you, but I wanted to share this with you here so you know what we're referencing. We'll pull this back a little bit later and talk more about it, but let's talk about the examples or samples that I'm going to work with right now. I'm going to work with a series of models that I created, simple models that will help to illustrate some of the concepts that I am talking about with respect to creating drawings and then putting dimensions on them. The first is the cutoff holder here. And then we have a stop pin, a hub insert, a feed guide, and then a gripping jaw. Okay, so we're just using these as examples to kind of go through the different workflow for creating drawings with Fusion and then putting dimensions on them. I will put all these models in and the drawings themselves in Canvas so that you can have them as to look at as samples and maybe even, provided you have time, do them yourself so that you can go through the steps. All right, so let's go to the cutoff holder first. All right, so we have a model of the cutoff holder here. All right, it's a pretty basic part, not too much detail. It has a rounded back surface here, two holes of the same diameter. We have a raised, what's called a boss pad right here. So we have a raised pad right there in the hole going through the horizontal portion. And then you'll notice that we have a kind of a channel or groove on the bottom. Okay, so we're done with the model. We want to start our drawing or create our drawing for this so that we can put the dimensions on. All right, and the procedure is going to go like this. So we're going to go to the work features over here, and we're going to choose drawing from design. Okay, then it's going to bring up the create drawing dialog box, and for all of our drawings we're going to use the ASME standard. Okay, the ISO standard is an international standard. It will have a different appearance and it has some different features. So we're not going to go through that. It would be too much to try to learn two standards in one class with all the other stuff that we have to do. So we're going to stick with the ASME standard, which ASME, of course, stands for the American Society of Mechanical Engineering. This standard was taken over from the ANSI standard, American National Standards Institute. So it really is just the ANSI standards, but now it's been renamed ASME standards. So we're going to choose that. The units for this drawing are in millimeters, right? So that's what we're taking there. And we're going to prepare it for a B-size sheet, all right, which is a 17 inches by 11 inch sheet of paper. All right. So up here it says full assembly. Of course, there's only one part, but that's kind of what Fusion calls an assembly. So if you take this check mark away, you're going to just have to pick that body, right? The the only body that's there. So you can leave that check mark there. And we say OK. And it's going to take us to the sheet, the 11 by 17 B-size sheet. Okay. And then as I move the mouse around, you can see that it's attached to it is what's called the base view. And you can see right there it says place the base view. We also see on the right-hand side a drawing view dialog box, and then on the left-hand side a browser similar to what we saw in the modeling environment, but different. I think you'll notice that it's different. And then, of course, across the top, we also have a ribbon that is different as well. All right. So we're kind of moving out of the model environment into the drawing environment. Our sheet has a border and a title block. All right. So first thing is we need to place our base view. Now, all of the drawing preparation really is there's a degree of iteration or a degree of kind of working with how best you're going to describe the object. Okay, so let me just take a second over here and I'll bring this across. All right, and let's look at whoops, where am I going? Right there. Okay, so the two objectives that a drawing has, an engineering drawing has, is to describe the shape of the part and to describe the size of the part and its features. Okay, the shape of the part is described with the views, and so that's really what we're doing right now. Is we're trying to figure out which views are necessary to fully describe the shape of the part. And when we do the dimensioning, that's going to be taking care of the size description. Okay, so first and foremost, we're doing the shape description. We're figuring out what views are necessary. All right. Now, when I talk about how this is kind of an iterative approach, that basically means that we can figure out what views we feel are necessary, and put them on the sheet. We may decide that we need another view. Or we may decide that we have too many views and we can take them away. So that's what I mean. It's, this is something that you're going to be working through to come up with the best solution. All right. So let me push this aside now and we'll come back to our model. And I want to place my base view. And you can see right now, before I click anything to place the base view, the scale of it is kind of small, right? Given the 11 by 17 sheet, this is too small, all right? The scale can be changed right here, all right? And we can change it either before we place the base view, like I'm going to do, or after we place the base view. And I'll do a couple of examples like that, but you can change it now or later. I like to change it now because it gives me a better appreciation of how all the other views are going to be shaped or located. So right now we're at half scale. So I'm going to switch to a 1:1 scale. Yeah, that looks good. And I'm going to put this right about here. Any views that we place down. So I place that, and then I'm going to hit the Enter key. And you'll notice that it switches it to basically what is in this case a front view. And it gives me all of the lines, the visible lines. It also converts edges into hidden lines for edges that are behind other edges in this view. Okay. Now let me also say that any placement that we have for the base view, you can see as I move the cursor over this, the view gets highlighted. Any placement of this or location of the base view can be changed. Right. So this is not written in stone. This is kind of like our first guess, or our first try at getting everything done. All right, so now to get the other views, I know I'm going to need a top view. And how do I know that? Well, because I have a hole right here, and holes should be dimensioned in their circular view, they should also be located in their circular view. So I know in order to do that, I need a circular view, which means I need a top view up here. Likewise, over here, I know I have a curve feature on this vertical element, and I know I have a hole right here. So likewise, I know I'm going to need a right side view to show the shape of those features, right? So I think we'll all agree that this single view doesn't really describe the shape of the part that we're intending to draw, all right? So in order to do additional views, we're going to go up here to projected view. Okay, and you can see we have a base view command, which we just did. We have projected views, we have section views, and then we have a detail view. So let's go to projected view, and it says select the parent view. In this case, the parent view is the base view. Now the parent view can be other views, right? But in this case, there's only one view, and it's the base view, so that's the one. So I pick this, and this is where Fusion just is awesome, especially if you're used to working with AutoCAD. Watch, we pick our base view, and then I move it up to get my top view, and I click with the left mouse button, and then I can move it back across here, or down, or over, right? So I know I want a right side view, so I'm going to click over here. Notice it automatically aligns it, so I have no opportunity to misalign things, to get things out of alignment here. So I'm going to click and locate that. And you know what? I could even show a view up here. I'm not going to do that right now, but I can do an isometric view down here, up here. So I'm done with all these views, so I'm just going to hit the Enter key, and they switch to the correct line types. All right, so we have visible and we have hidden lines in this case. Okay, if we look through everything is good, right? Because it's pulling the lines from the model. Okay. So what's next? Well, once we're satisfied with our views, that is to say, once we feel like we've described the shape of the object, and I feel like we have described the shape of the object, we don't need any more views. We've described this vertical, the curve here, which is important in this hole, and we have in the top view the boss and the hole for that. And we've also shown the profile of the notch down here. Actually, not the notch, the rail, right? So I think we're good to go. So the next step that we want to do is we want to put center lines and center marks in here. Okay. Now, we could actually go straight to dimensioning, but I like to put the center marks in there because I feel like that is the next logical step before dimensioning. Okay. So the center mark and center line command can be found right here. There's an additional one here, center mark pattern, which we're not going to use in this part. But so for the center line, what we're going to do is we're going to pick two offset parallel lines, and it's going to do a center line in between those two. All right, so again, right there. Now notice that it extends it beyond the edge of the object, which is correct, right? So again, we go here and here, and we go here and here. Okay, so that's it for the center lines. Now let's do the center mark. So we go up to the center mark command, and now here we're going to choose a whole or rounded edge. All right, so in this view, I'm going to pick the outer circle here. Now this is an important point. You always want to pick the outermost diameter for the concentric circles. So I want to pick this line, because then my center marks are going to go through the boundaries there. Now, let me undo that. There we go. And let's do that again, but let's pick the smaller one, the smaller diameter hole. You can see that that's not appropriate, right? We want the center marks to go through the largest circle. And there we go. All right. So let's do that again. We put the center mark in there like that. Now over here, there's actually, Fusion has an issue with this, okay? For Fusion, there's a rule that if you apply a center mark in a circular feature that is not a complete circle, it will only put a small plus in there. So if I go to this, it puts the plus. That's not appropriate. Okay, so I want to undo that. Undo that. There we go. And what I need to do is do this. But now we have a little bit of an issue. Okay. And this is actually a good segue into what's necessary for refining the center marks and center lines. Okay, so as much as possible, we want to use what the center marks and center lines define in our drawing. So in other words, the center mark, if we look at the center line and center mark for this hole, right, it really represents a feature that is symmetrical, right? In a hole, the left side is the same as the right side, and the top is the same as the bottom. It's cylindrical, right? The center mark and the center line help to say that. It says, hey, this is a symmetrical feature of size. Right. In our design, we might also want to say that things are symmetrical. In other words, I might want to say clearly that the right side of this object is identical to the left side. Right? And the reason why I might want to do that is because it will help with our dimensioning. All right? It will help eliminate dimensioning or make dimensioning more clear, or I should say the understanding of the part is made more clear in that way. Same thing up here, right? We don't want to leave it to guess that the top and the bottom are symmetrical and that the line of symmetry goes right through there. We want to state it with a center line. So what we're going to do, and I'm going to zoom in here, is we're going to do some manipulation. So I'm going to click on the center line, and I'm going to grab with the mouse, click on this end, this is called a grip, end grip, and I'm going to stretch it right to there. And so I've kind of stuck these two lines together. All right. Then I'm also going to click on this, and I'm going to grab this, and I'm going to come out, not right here, right? Because I want it to extend slightly, and I'm just going to eyeball this right about there. Okay. So now what I've done is, by making the center line go through the whole part, I've basically said that the top and the bottom are symmetrical. And in fact, the part is symmetrical along its longer axis. That should also be here because that's the same axis. So I want to take this, I'm going to grab this, and I'm going to pull it down to the end there. And I'm going to grab this one, and I'm going to pull it up until it looks about right about there. Okay. I don't need to pull these out to the side because this is not part of the circular feature, right? This is a straight line or a straight surface. Okay. So there we go. All right. So I'm pretty satisfied that I have my three views properly created. That they're arranged pretty well. I may decide that I want to space out these views a little bit more, but maybe I'll wait till I get dimensions on there. By the way, when you move views, it's very simple. We just click in the space, and then we grab the center, and we click and just move it. Notice that it maintains alignment, so the right side view moved down with the front view here. All right. If I move this view, watch, if I move this over here, whoops, it's not going to let me do that, right? Because that would break it out of alignment, all right? Now, could I do this over here? No. Can I do this down a little bit? Yeah. Okay. So it will, let me undo that. It will prevent you from making moves or from moving it out of orthographic position, which is very good, very helpful. All right, so let's get to the dimensioning part of this. Okay, so I mentioned that we're going to follow our two-step procedure, and the two-step procedure is here. Step number one is dimension the sizes of individual geometric shapes. Okay, so what are we talking about with individual geometric shapes? Well, we're talking about cylinders and holes, right? We're talking about rectangular solids, right? And in this case, that's really it. When you look at this part, it's really just made up of a whole bunch of cylinders and rectangular solids, or prisms, right? Now we have a positive and negative shapes for that, right? A positive cylinder would be like this boss, right? Something that we can touch. A negative cylinder is like a hole, right? We can't touch a hole. You can touch the sides of the hole, but you can't actually touch the negative space, all right? So I'm going to go through and do step one, all right? Dimension the sizes of individual geometric shapes. Now remember, these are all three-dimensional shapes. So how many dimensions do they have? Yeah, you're right, three. Three-dimensional shapes have three dimensions, okay? Now in some cases, so for instance, with a diameter is basically two dimensions in one, all right? So just watch up here. So for dimensioning, I don't like to use, let me say, this dimension command, all right? This dimension command, if we use this, they say it's kind of like an intelligent dimensioning command. So if we move over that, it'll give us an automatic dimension. If we move over this, it'll say, oh, that's a circular feature, so you want a diameter. If we move over this, it'll say, hey, you need a radius for that. If we move over here, it says, nah, that's a line, so you need a length. This is not really good, okay? It's like for lazy people that can't be bothered to actually figure out what they're trying to do, all right? Clearly, this 73 is wrong, right? Clearly, this dimension right there, the 48, is wrong, all right? So I would implore you to avoid this command, all right? Instead, use the specific commands right here, okay? So let's go to diameter, because I know I need the diameter of this, all right? Now, in fact, there's two diameter 13 holes. So I'm going to hit escape. I'm going to double click on this dimension. I'm going to position the cursor in front, and I'm going to type 2x space, because that's the way that we indicate multiple features of the same size. All right. So holes are dimensioned with a diameter in their circular view. So I just did those two holes right there. That's two dimensions. I need the third dimension, which is going to be the depth of the hole. So I'm going to do this from here to here. Okay. Whoops. Now I know that that's wrong, so I grabbed part of the curve. So let me go back over here, and let's do this from here to here. There we go. That's better. Okay. Now I know I'm missing the top part up here, but we'll take care of that in a second. So we got these two holes. Oh, I need a thickness for that hole, which is 13, which is correct. Okay. These are linear dimensions. Let's get the boss pad. That's a diameter. Cylinders should be dimensioned in their rectangular view. So this is the rectangular view for that. So I'm going to pick the two edges right there, pull that up. Now I need to say that this is also a circular feature. So I need to add a diameter symbol there. So I'm going to double click on the 28, position my cursor in front, and go up here to diameter. And say close, and then there we go. What else do we have? We have a radius right here. So I'm just basically marching through the different features of size. So we have cylinders, holes, we have a radius here. Next we have a rectangular prism, which has three dimensions, a length, a width, and a thickness, which I already have with a 16. Okay. Now, if you're wondering, why did I put the 89 up there? Well, it's a good question. Some of this is going to be a judgment call. Okay. And just like we all know, some judgments are better than others. Okay. So I could do the 89 there. I could do the 89 here. I could even do the 89 up here. Heck, I could even do the 89 right here. It's your job as an engineer to figure out what's best, all right? Because now we're talking about gray areas, all right? But there's a better option. There are better choices and there are worser choices, okay? So let's just talk about these. So this choice right here, we want to, as much as possible, we want a dimension between views because that helps us to refer to dimensions between the two views. So I'm going to get rid of this one because it's on the top. All right. This dimension right here. Well, let's look at this one. This dimension right here. You know, there's too much that this dimension kind of obscures or this is an overly complex view for this dimension, right? Because we have some gap and we have some other features in here, this other dimension. So I think that this is also not good. Now, we're left with two, 89 up here and the 89 down here. And arguably, in different situations, you could choose one or the other, all right? Now, I like the 89 up here because in conjunction with the 54, it gives us the footprint of the whole part. All right, so notice if we have the 89 down here, the 54 has to stay up here, or at the very least, it's going to be put over here. Okay, so that's why I like the 89 here, and that's where I'm going to leave it. Okay, as long as you rationalize and talk through each one of your choices when you come to this fork in the road, this proverbial dimensioning fork in the road, you know, you're going to be making hopefully good choices. All right, if you can justify what you're doing. All right, so we got that. Now we need this one right here. Now recognize that this feature right here has a curved top. We need to know the location of this feature, but we also need to know, you know, these lines are tangent. So what we need is we need the height here. Okay. And yeah, what else? I think that's about it for that. Oh, you know what? This cylinder, how big is the cylinder? Well, the cylinder is, I told you I would put this on here. The cylinder is 3. Now I'm going to show you, this is a common occurrence, right? You get dimensions over dimensions. So I'm just going to place it down here. I'm going to hit escape a couple times. And you can, after you place the dimension, you can manipulate its location. So I'm going to click on the 3 and I'm going to grab that grip box and I'm just going to move it up here. Okay. And we'll just eyeball it right there. And then there we go. Okay. So if I want to put this 13 inside, I could click on that and I can move it right in. And it goes like that. Okay. So the 17, if I want this a little bit closer, I can click and kind of move it down there. And this is a very common thing. You're going to need to kind of massage your dimensions into a better location in many cases. All right, so do we have all the sizes taken care of? We got the cylinder, the hole, the radius, the vertical part, the width of the vertical part, and the horizontal part, the length and width and thickness of the horizontal part, thickness of that too. The only thing we're missing is this rail right here. All right, and the way I'm going to dimension it is I'm going to use symmetry, and I'm only going to dimension from here to here. Now, in the presentation that I'll do about dimensioning, you know that it is a cardinal sin to dimension hidden lines. So it is completely not appropriate to dimension that there, okay? Using hidden lines to dimension is a big fat no-no. All right, so we get rid of that. And we need a thickness for this, right? So this is like a 38 millimeter wide prism glued onto the bottom. I also need a thickness here, so I'll put it right here. By the way, you'll notice that I picked this edge right here instead of this edge. Let me show you. Let's look at the two of these. So let me put that there. Okay, so that's fine. And let me do the wrong way to do this. So I'm going to pick this dimension and this dimension, or that edge and that edge. All right. So you see the difference here? It's very subtle. Right? Kind of looks the same, but notice here we have a gap, and here we don't have a gap. We want that gap. That gap is important. So in this case, this is wrong. All right. Now, can we change that? Sure. We could erase it and redo it. We could even grab the end here and move this back here. Maybe it's going to let me. Maybe it's not. I'm not sure. There we go. And we could, yeah, it's not really going to let me do that. There we go. Okay. The bottom line is, you know, don't make that mistake in the first place. Okay. Do we want to fix this? Yeah, watch. We could go like this. We could make it look nice and pretty. We'll click on that and we'll go right to there. Oh, look, it won't let us do that. Huh, very interesting. AutoCAD will. So that's what I was thinking, that we could do that from AutoCAD. I'll move this apart a little bit to make it more clear. Everything looks good. And if you're wondering, how does this center line and this dimension make it symmetrical? Well, in the same way that the diameter right here means, what does the diameter 28 mean? It means that the distance from here to here and the distance from here to here are the same, right? The distance from here to here is 19. The distance from here to here is also 19, right? So do we dimension the diameter 28 and then add the 14s? No, we don't do that. So in the same way, we put the 38 and the center line goes through that right there. That says, hey, you know what? If that's 38, this is 19 and this is 19. Okay. Same thing up here. This hole and cylinder are located by virtue of the 54 and the center mark going through the whole feature. So when we move to step 2, because we're done with step 1 now, step 2 is dimension the location of the shapes with respect to mating surfaces and functional requirements. Step 2 says, hey, where is this hole and cylinder located? Well, it's located from the edge to here and from the edge to here. Okay. Now notice it moved that off, which it should. It has an appropriate gap. Over here, it didn't really do that, but you know what? I don't need that 27. That's what I was just saying. We can just suffice with the 54. All right. Now this going through the 38, that's a no-no. So I'm going to click on that, and I'm just going to move this where it looks good. Maybe right there looks good. It can go through the extension line here. That's not a problem. It can even go through the dimension line, but we don't want it to go through the number. That's bad. Actually, we can move this down a little bit. That's a little bit high. There we go. And I can move this in a little bit. So now it's just a question of massaging everything into place. This is all good. Actually, I like the 3 on the inside and the 16 on the outside. So I'm going to do that there. Some of this is just fine-tuning it just to make it more readable. Okay. That's the only location dimension that we need in this. okay? Because we've already located this hole with the 41. So the 41 doubled as a size and a location dimension, and that's very common, okay? Now, so we're done with dimensioning this, all right? Now, a couple things about this before we wrap this up. It looks like all the lines are the same shape, are the same line weight, but really they're not. They're going to print thicker, and it might even help you see things better if you view the thickness of the lines. So if we go to the document settings and we go to display line widths, right, and we can click on that and say, see, it's right here. If we hover over that, I don't like the way it truncates this right here. You can't really resize this easily, but if we put a check there and say okay, right, now honestly that looks pretty good, right? That actually, I would probably rather put the dimensions on with that, because it just helps see things a little bit easier. Okay, so that's the line weights. It's going to print with this anyway, so even if we didn't turn this on, it will print correctly. All right, so this is just for visualization purposes. Now, I do need dimensions, or excuse me, I do need notes. All right, so there's a few notes that are going to be standard, and I'll show you what they are. So we go up to text, and I'm just going to open a big text window, make sure it's big enough. All right, and I'm going to say in all caps, unless otherwise specified, :1, all dimensions in inches. No, in millimeters. Drawing and dimensions per ASME Y 14.5-2009. That is the standard, basically the rule book for this. So basically this is a statement that these dimensions and the views were created according to the ASME Y 14.5 standard, which was revised in 2009. Okay, so you want to include that. And the only other note that we need on this is fillets and rounds, because you're probably thinking, I forgot about these fillets and rounds, but I did not, because it's most commonly dealt with in a note. So I'm going to say all fillets and rounds are 3 for radius 3. So I can come over here and say close, and then I get that. Maybe I want to move that a little bit. That's kind of, there we go, that looks better. And then last but not least, we're going to work on the title block. So let me zoom in here. The title block is real easy. You just double click on one of the lines, and then it shows you all the text that you can change. Okay, so the project, this is going to be the name of your folder, right? My folder is EGN 150 master, so that's where it's coming off there. This is the title of the model. All right, we can assign a subtitle, actually 2 subtitles if we wanted to. Approved by, well, that's going to be yours truly, C. Bales. Checked by, hey, the same guy. And then drawn by, it's pulling this in from the name on your Fusion account. Okay. Scale is automatically set at 1:1. Size is automatically set to B. We're not going to do a code. The drawing number, whatever drawing number this is, so drawing, I'll make something up, 2.75, right? Each of the parts that you're drawing have drawing numbers, so use those. The weight is not applicable. Revision, this is revision 0, right? This is the first instance of that. And that's it. So then I can say finish properties, and that's all good. And then what you're going to turn in is going to be a PDF version of this. So you're going to go to Output PDF and All Sheets. There is only one. And I'm going to go ahead and say Open PDF so I can show you. I hope it does open. I've been having trouble with some of this, so we'll see. So, and line weights, of course, needs to be checked. So we say OK. And let's save it. I'll call it Cutoff, Holder. And there it is right there. All right, so I'll resize this a little bit. And you can see, and when I zoom in, you can see the line weights. There we go. All right. So this is what you'll be turning in to me. Of course, with notes, with a completed title block, with all the dimensions and the views. Okay. I did forget one thing. I did forget an isometric view, which I think is in the instructions, is a nice thing to add. It's I'll just close that out and we'll add that. It's really an easy thing to do. We're going to go to Projected View, click on that, click on this view, and then project that right there. Now watch. I'm going to put that in there, hit enter. Now, that's not the style that I really want it, right? So I'm going to double click on that, and I'm going to come over here to the different style, and I'm going to choose shaded. Okay, so that looks good. And, you know, I could change the size 1:1. I could make this 1:2. Let's see what that looks like. Yeah, that's too small. So let's go back to 1:1 from parent. And we'll say close. All right, and there we go. Okay. So that's a good view. I think that's nice because it helps explain possibly to the machinist or the person creating this part on the shop floor what their end result should look like. Okay, so I'm going to need to print this again. So save this, all sheets. We'll say Open PDF. And we'll save it again, same name. And then we'll look at this again. And you can see our nice drawing. And we're ready to turn this in. Okay, so I'll have a couple more examples to do where the complexity gets a little bit more. And I'll just talk you through all this stuff. So I'll see you in the next video. Bye.